Good afternoon, and welcome to today's webinar titled Wood Innovations, Exploring New Forest Products. This is the third installation of the Northern Forest Center's Today's Forest Economy webinar series that examines current trends, innovations, and challenges for the wood products industry in the Northern Forest region. Today, 3 industry professionals will discuss their work in bringing mass timber, biochar, and wood fiber insulation to market within the Northeast. My name is Amy Robinson, and I am the Business Innovation Advisor for the Northern Forest Center. My role includes providing business technical assistance directly to primary and secondary wood product businesses. Before we begin today, I'd like to share a few housekeeping items. In the chat box, please tell us who you are and where you're from. This webinar is being recorded and the link will be shared in a follow-up email, and you can also find it on our website. If you have any technical issues, please message Kendall Gray directly in the chat box. And we encourage you to drop your questions in the Q&A box, which is located at the bottom, as we have left time at the end of this webinar for questions. The Northern Forest Center is excited by the innovation and the local impact of the wood product sector on Northern Forest communities. Our panelists today and their businesses are excellent examples of this innovation. I'd like to now transition to Joe Short, who will be today's moderator.
Thank you, Amy, and welcome everyone. Thanks for joining us. I can see our audience filtering in, and I'm looking forward to today's conversation. As Amy noted, innovation is really a constant in the wood products industry. I think we see it every step in the supply chain, from foresters to loggers to processors. People are constantly innovating in how they do business. We see things like artificial intelligence and drones finding their way into forest management. Silvicultural processes are always evolving with new science and as new markets evolve, and manufacturers are constantly tweaking processes, conceiving of and often building their own equipment to do the things they want to do, implementing robotics, all towards efficiency in production and in the use of wood. And the Northern Forest, this region, has a long history of producing forest products in ways that keep forests as forests and support rural economies. At the same time, as markets evolve, as they constantly do, there's always need and opportunity for innovative products that make good use of forest resources and create goods and services that people in society are asking for. So today's webinar will highlight 3 examples. We could have chosen from many more, but we brought you 3 today of new products and the companies behind them. And we hope that this conversation will inform and inspire you about innovation in the forest industry and prompt some good questions and discussion about what it takes to bring new products to market. So our format and flow today, we're going to start with an introduction and an overview from each business, about 10 minutes to learn about their product and their company story. And then we will have a little discussion with our panelists before we open it up to your questions and comments. So as Amy noted, please use the Q&A feature to register your questions as we go, and we'll pick those up in the discussion portion of our agenda. So let's get started. We're going to begin with Amelia Baxter. Amelia is the CEO and co-founder of WholeTrees Structures. I've gotten to know Amelia and her company through a project we supported with the town of Ashland, Maine, to help bring, we hope, markets for structural round timber to Maine. So Amelia, thank you for joining us, and the screen is yours.
Thanks, Joe. Let me get everything popped up. How is that?
Looks great.
Great. So hello, everyone. My name is Amelia Baxter. I'm CEO and co-founder of WholeTrees Structures. We're a 15-year-old company. We founded in 2007, and we bring structural round timber or unmilled timber in structural form to commercial construction, generally in the form of columns, beams, trusses, pre-engineered assemblies like amphitheaters, band shells, pergolas, solar carports. And we do this by leveraging the innate superior strength of unmilled trees. A round piece of wood is 50% stronger than a milled piece of wood with the same cross-sectional properties. And that engineering brilliance of the natural tree is really is part of the inspiration of our company as we founded. So this presentation is a little bit about our company, but also about how we have been focusing towards Maine source structural round timber and our plans in Maine for East Coast markets that we've been serving. To begin with, we at WholeTrees consider trees as the original skyscraper. What you're looking at here is a 1400-year-old temple in Japan where the structural round timber columns are created in tiers to support what would be today considered a 10-story building. Most of the timber, the historic original timber, is still in use today in service in this building. And this building is, of course, in a seismic zone 4 in Japan. And so it's an impressive proof that wood works well over long periods of time. We at WholeTrees bring to the building industry. So when I say the AEC community, that's architects, engineers, and contractors in commercial construction. We try to remind the AEC community that structural timber, solid sawn timber, like the beams you see in this image here, which is a building, a beautiful renovation in Lewiston, Maine, and structural round timber, which are the columns you see in this image here, that these are not unknown or risky building materials, but they're actually quite intelligent with a long history. SRT, as I'll call it in this presentation, and SHT, sawn heavy timber, they can be sourced from certified forests that are managing their resources to the kind of the maximum credentials that we have in forestry today. SRT structurally sound, it's code compliant. The fact that it has such minimal processing means that it has a lower embodied energy. It sequesters more carbon and it releases fewer global warming potential elements. SRT and heavy timber in general has a fire rating equivalent to engineered mass timber products. And it is generally less frequently used today than, say, laminated wood products or steel and concrete, because of changes in the way that we've managed our forest over the last 200 years. I'll talk about that in a moment. So at WholeTrees, we also enjoy reminding the AEC community that trees are the original mass timber. Mass timber is, in brief, a definition for any timber structural product that is massive enough to have fire ratings of 1 hour or greater, which is what's required in code for commercial buildings. And so any wood product that is larger than 8 inch by 8 inches, and at times it's 5 by 5, depending on where you are in a building, can withstand fire for 1 hour to 5 hours, depending on dimensions. And so mass timber, as we study its capacity to handle fire, we've been able to also innovate its engineering properties and create a sense of a new palette of laminated products, such as CLT, cross-laminated timber, glue-laminated timber, NLT, DLT. But what you're looking at here is a Revit model of structural round timber columns and truss systems that were designed by WholeTrees consulting engineers of ours, as well as the architect Malcolm Holtzman of Steinberg Hart in Manhattan, and you'll see this image later as well. So we consider trees as the original mass timber. So I'd mentioned that mass timber became popular in the North America, first in Europe and moved through Canada and then into the States. This awareness that our forests are younger now, and we've basically used up the bulk of our old growth forests, and we have a lot of small trees with great engineering and mechanical properties. And so if we could take those smaller trees, mill them up, glue them back together, we could analyze the structural properties of this new engineered thing. And as that industry grew and spoke about the carbon benefits of sequestering carbon within the built environment, mass timber, the interest in mass timber grew in our society. So what we at WholeTrees have really benefited from the conversation that has happened around why we need to be bringing structural wood into commercial construction at scale, that there can be great benefits to forest management, and there can be great benefits to climate issues if we can store more carbon in our forest and in our tree and in our buildings. So what we at WholeTrees get to do is bring products into that, that palette of mass timber opportunity and offer trusses, columns, and beams. What you see here on the left is a junior high school that we contributed the structural columns throughout the building and on the exterior, paired with glue laminated beams and nail laminated timber. WholeTrees offers digital tools to designers that then can be designed into CAD systems to then result in buildings like this children's museum that you see on the left of this image. You'll see a little more later. SRT and SHT both allow for a regional sourcing that can be a little bit more specific to a region's forestry systems, as opposed to laminated products that often require large swaths of one kind of timber being grown in one area of the country and then shipped to manufacturing centers, sometimes in another area of the country. Mass structural round timber meets building codes, and because it's considered a heavy timber, which is already quantified and explained in the International Building Code. I mentioned earlier that trees resist fire. They tend to char from the outside in, maintaining their structural capacity. And trees, as this webinar probably already understands, are very efficient. What we've been able to do in the last 2.5 years is work with partners in Maine to bring the original mass timber Maine, which is a brand separate from WholeTrees or any specific forest in Maine, and talk about how SRT and SHT could be specified or utilized by commercial construction industry. So I want to briefly just talk about what we are doing in Maine. We have been building a case first that the markets exist. WholeTrees, who's headquartered in Madison, Wisconsin, and fabricates product in Wisconsin as well as throughout the country. We don't have a method of fabricating our material or sourcing easily from northern forests in New England. And we have a market. We ship product from Wisconsin to the East Coast on a regular basis. So we're interested in opening a fabrication facility in Maine that utilizes Maine's incredible fiber basket. And so we've been driving East Coast markets for northern Maine source structural round timber. And now we're continuing to, due to the success of this initiative, work towards the ramp up of a facility that fabricates structural round timber systems in Maine. There is a strong market that can tolerate the price point of shipping from Maine throughout major urban cities in the eastern coast. But we've also found that we can sell structural round timber from Maine, and actually the price for shipping all the way into the middle eastern states can be tolerated by our clients. We intend to help private sector, we've worked with the Northern Center to help private sector entities like WholeTrees to scale towards this opportunity on the East Coast. And we continue to work towards that right now. We are bringing all of the benefits of structural round timber to our markets, and we're finding that there's a great interest in the use of technology to ascertain geometries of the columns when we use unique organic forms like this sugar maple that is on the Seven Islands Land Company land. That's my time. And so what you can see here is that we scan our timbers, we bring them into structural application. This is a children's museum that has northern Maine sourced sugar maple serving as structural columns throughout a 2-story mass timber building in Eau Claire, Wisconsin. Another image of that. And I think due to time, I'll just mention we have worked with UMaine to study both the cost comparisons of structural round timber columns in a 3-story building compared to glulam columns, as well as the environmental impacts of structural round timber sourced from Maine in a Maine 3-story building versus sourcing a laminated product from away that and had a really beneficial comparison point. And this is what our 3D model looked like when glulam was used to hold up this 3-story humane hypothetical building. And here are some of our 3D models. What we have are sugar maples again in the lobby, and then hemlock structural columns, 15-foot columns throughout the full 3-story building. This is the kind of work we get to do nationally. We get to expand what we do every year. We solve new problems in structural round timber as a mass timber element in buildings. We get to solve bigger problems, higher structural loads, taller buildings each year. So it's been a exciting and kind of a nonstop ride at WholeTrees for 15 years now. In the interest of time, I'll stop. I'll let you know that we do have data on that case study that I mentioned at UMaine. And I'll end here in terms of how WholeTrees sells to the architectural specifier community, works with engineers, often helps construction projects select or inventory material that they hope to use in their buildings, and that we then deliver our product to building sites throughout the United States, and at times provide installation services as well. So that is who we are. Thank you very much.
Amelia, thank you so much. And no, I love that story of these, those sugar maples from Seven Islands now standing in that awesome atrium in the Children's Museum out in Eau Claire. And I think, as I'm guessing many folks listening to today's discussion are aware, mass timber is something this region is excited about. There's a lot of effort and I think an enthusiasm about attracting manufacturing of mass timber from northern forest wood into the region, but we're not there yet. And I think your project has demonstrated one way, actually, that mass timber, as you said, the original form of it, is in fact able to come to market right now. So thank you for getting us started in a great way. We're going to turn next to Donna Pion, who's the general manager of Green State Biochar. And I think, it's important that we have markets for all the grades of wood and types of wood that come out of the northern forest. So Amelia just talked about literal use of WholeTrees. And Donna has a product, I think, that is thinking about use for residuals and lower grades of wood as well, I think, to demonstrate innovation across that whole value chain. So Donna, we'll turn the screen to you to tell the story of Green State Biochar and your product.
Oh, hello, I'm Donna Pion, and I am the general manager at Green State Biochar. And I thought that I would start the presentation with our YouTube video that was done for us by Elizabeth Rosano, wonderful videographer here in Vermont. It was funded by the Center for an Agricultural Economy here, also in Hardwick, Vermont. And just so you can get a glimpse of us making the biochar. We make small quantities of it. As the biochar industry is growing, you're now going to be looking at companies coming in to mass produce this biochar. We can produce 50 tons a year. I'm working with another company now who's interested in 3,000 tons a year of biochar. And keep in mind that every ton of biochar takes 4 times as much waste wood to produce it. So every time I make a ton of biochar, I need 4,000 pounds of wood chips. So if we can, I thought we'd start with the YouTube video, and then I was going to go into a small presentation about what we've done with the biochar we've been in business 5 years. So and we all know what 2 of those years were like. So if we could start with the video, I think that would be a good place to go.
Okay, we will get that up. Hang tight. These things sometimes take a second in the Zoomiverse.
I'm just going to run a quick calculation here anyway. So
All right, looks like we're nearly there.
My equipment, Luke and I built, it's the engineer, John Forster, that I'm working with. He says it's good old Vermont ingenuity, he said right there.
Luke and Roger started building this machine, and it was a good quality biochar because we actually had it looked at by a couple of specialists. Biochar is a product produced from biomass waste.
It almost by accident will help solve the problem. You just put it in the soil, that's it.
Biochar has highly absorbent properties to capture runoff, to remove detergents from the cleaning waters. It can be used as fertilizer. It can be used direct application to remove algae.
Sequesters odors amazingly.
It has ability to produce energy while you're running the machine.
Our machine is really, really unique from the ones that we've seen.
It runs continuously rather than the batch system. All the gases that come off the wood as you get them up to temperature are redirected back underneath to run the machine itself. So it's almost perpetual. When farming was simple, it wasn't that hard for people to make money. The margin between profit and expenditure is very tight now. Back then, you could go buy a new tractor once in a while.
Manure management is, harder. I mean, the runoff is already polluting our lakes. We have this green algae that's popping up everywhere.
Small farmers are going to be impacted by Act 64. It's the Clean Water Act. It's an attempt to, clean our rivers, lakes, and streams. And they're going to be coming around to visit those small farms. And they're going to need solutions to control runoff from manure pits, from their fields, from excess use of fertilizer. And biochar is a solution. It's a low-cost means to solve these on-site farm issues. Where are we going to be without clean water?
We need to take care of the stuff that we have because we're not getting any new.
We want to treat our environment as nice as we can so it lasts for, the next generation to enjoy.
After a couple of years, it becomes apparent that this is a great fix at a low cost. Then we feel we've done something.
So Kendall, can we go right into the slideshow now? Kendall?
We will
Oh, okay.
get that right up.
All right. Well, thank you for allowing me to show that. I just think it's important that we're making our own biochar, but also how the industry is growing. And it's clear that our machine is not going to be able to keep up with the demand for biochar, which is a good thing for the waste wood industry. So that's where we are right now. All
right, just waiting for your
yeah, for the
slides to appear. Sorry,
Yeah,
everyone, for the
okay.
lags here. Here we
Yeah.
go.
So we did start. Actually, Roger and Luke, I can't take credit for biochar. When they started talking about wanting to start another business, and because we already have a trucking company, an excavating company, and they started talking biochar. I of course said, bio what? What are you talking about? But they went about and built that kiln, and then the Vermont Phosphorus Innovation Challenge came up, and we decided, well, let's use biochar. Can I advance these, or Kendall, will you advance them for me? There you go. Thank you. So that's what we did. We filled out the paperwork, worked with an engineer, and got our foot in the door, putting in biochar filters to capture the runoff from dairy farms. And we were primarily interested in capturing the phosphorus that was coming out of the barnyard cleaning waters and any excess from the manure pits. We built some holding ponds. We would test the effluent when it went into the holding pond, and then we would measure we would bring the samples after the it went through the filters to see what kind of phosphorus we were capturing, and we were successful at capturing up to 95%. After about 8 months, the filters started to not hold as much, and that's when it became time to remove the spent material. Can we go to the next slide, please? So this was just preliminary, setting up the filters, putting in the holding ponds, and that's where it all began. We'll go to the next slide, please. Then we also did some side-by-side comparisons where we would run biochar. We would run the effluent through one filter that had biochar and another which had sand. And sand is an excellent material to use to capture phosphorus. The problem is it clogs very quickly. And then we just ended up with a bunch of sand with phosphorus that you really can't do anything with, versus the biochar. Now it's nutrient rich and it could be used as a soil conditioner, put back onto fields, used in greenhouses, used for consumers, so many things you can do with it. If we weren't capturing it, the runoff off of dairy farms, but instead we're using it in stormwater, because they are using biochar to capture heavy elements from stormwater, you can then put the biochar back in the kiln and eliminate the contaminants that you don't want. Can we go to the next slide, please? We also did more we just heavily tested for like 3 years just to see if this biochar was really going to work as a material, as a filter material, and it does. Here we actually went to dairy farms and collected manure from manure pits and brought it back to our test site, where we did the same thing. We ran it through filters with biochar. We ran it through filters with sand, just to see which one we'd get the better results with. Can we go to the next slide, please? And this is why we do it, because it matters. It matters that we're able to mitigate the runoff that's happening, that's causing blue-green algae everywhere, that farmers are being blamed for wholeheartedly, and it really is not just their thing. If you look at homes with camps along lakes, aging septic systems, they're all part of the problem. Can we go to the next slide, please? And we do have customers. So our customers are farmers who want to use biochar to increase their crop yields and build healthier soils, sequester carbon. Consumers can use biochar, again, in their own gardens. Landscapers, if you take biochar and put it under sod before you lay the sod, you're going to use less fertilizer, so you're going to save money on fertilizer costs, as well as it takes less water. When you put biochar in the ground, it actually holds on to the water and doesn't release it until the roots of plants need it, which is, great during drought circumstances. Local and state municipalities are happy to use biochar to capture stormwater runoff. Riparian buffer zones, you can actually build them by using biochar. So that's what we're doing with it now. And we do have some long range plans, but for now, this is where we're going with it. Can we have the next slide, please? We sell our biochar in 5-gallon pails. We also sell it in 2 cubic yard sacks, and we're happy to fill up dump trucks if you're so inclined to want that much biochar. Keep in mind, our biochar is more expensive than when megachar comes into production, which will be in the next year and a half. We're getting $4 a pound for our biochar. Megachar is going to be charging around 40 cents a pound. So you can see we're going to have to work closely with those Megachar producers. Next slide, please. There are other companies now producing biochar. They sell it in Black Owl Biochar, makes a blend for stormwater. Wakefield Biochar also has different blends for different applications. We're primarily just selling straight biochar, except for the biochar that we've pulled from the filters from the 2 dairy farms, and that's inoculated biochar, which is phosphorus rich. Next slide, please. In Europe, they're actually able to feed biochar as a supplement for dairy cows, and it helps to it helps with the liquid. There's a more technical term for this, but I don't know it. So the solids are better when you feed it to a cow. Right now, a cow produces 15 gallons of manure a day. 85% of that is liquid. When you feed the biochar to the cow as a supplement, you're ending up with a 70% liquid and a 30% solid, which is actually better for the cow as well. They're also using biochar as a bedding material to absorb the ammonia odors in poultry farms. And the chickens eat it too. Next slide. So that's who we are, and I'm happy to answer questions. I think that what we can contribute is that we are going to, as biochar production increases, we're going to be able to readily use that waste wood. And right now we're working on collecting how much we can get, working with some local loggers for this upcoming project. We're going to need 12 million tons of waste wood to produce the amount of biochar that this new unit will produce. So that's a lot, and we need to have that steady stream of waste wood available to us, which is why we're starting to collect all this information from loggers, sawmills. If you have any loggers, please have them get in touch with us, because we're going to be happy to take that waste wood away from them.
Thanks, Donna. I think that's a great example of, how you all as a business have responded to particularly a need and a connection to the agricultural economy there in Vermont, and figured out how biochar as a wood product fits into that. And I'd love to, and I'm sure our audience is interested as well, to come back to that scaling up of biochar production that you were describing, and talk a little bit about that when we get into our discussion. But for now, thank you. And we will turn next to Jason Todd, who's the Building Science and Industry Support Director for a company called TimberHP over in Madison, Maine. TimberHP has gotten a lot of, I think, great attention in recent years for the product they're bringing to market that could displace fossil fuel-based insulation products with one created from cellulose and wood from our region. Again, thinking about markets and market opportunities and product opportunities that can replace markets that have slipped a little bit for things like pulp as we make and use less paper. So Jason, we will turn the screen to you to tell the TimberHP story and the innovative product you all are bringing to market.
Thank you very much. So TimberHP is also a wood products product, focuses on residuals. And we are going to market in a few months, coming up very soon. We're going to flip the switch on our first production line, our first product in April, and very excited. It's really starting to come together. Our focus in going to market is a insulation product that I would say is in a realm that is not often very innovative. The last major innovation that I can think of in insulation would be spray foam, and that's been around for quite some time. But our focus in going to market is HP ×3, high performance, healthy planet, and healthy people. And we really want to lead with high performance. We want the conventional aspect of insulation to be the important part as we go into market and hopefully become something that's very familiar to everyone. As you can see, a very conventional application, and our focus is getting into walls, attics, floors, ceilings, wonderful, great attributes that I'll talk to as well in the presentation. There's our market ramp, or going to market ramp, and like I said, the spring timber fill we released. We'll be releasing bat towards middle of summer, and then by fall the timber board. And all of these are fundamentally the same material with some additives along the way to provide the structure or the density, depending on the application. It's not a new technology. It is here in North America, but it is 20 years in the making overseas in Europe. I think it's an important distinction to make that there are more than 15 manufacturers that have been producing this product for over 20 years in Europe. That $800 million is probably closer to $1 billion at this point, as those manufacturers have expanded operations in multiple locations in Europe. And it's certainly a significant part of the market overseas. It's still seen as somewhat of a specialty product, though. There are reasons why, but we feel like it should be a plain old conventional first choice here in the States and in Canada. I've got a little video. We'll try to just run this real quick, give you an idea of what it's like overseas and what you might expect with some variation here in the States. And for those of you that are familiar with the building industry, there might be some familiar things in that video and maybe some applications that are maybe a little backwards or different. And one of the big things that we've been doing here and my work is translating some of that to what we do here in the States. Much more variety of climate zones and applications, but a good fit with the wood basket here in the Northeast, with our first production facility in Madison, Maine. The involvement from the forest products community, from loggers, from retailers, contractors, and architects. We feel like we've got a great path forward and are looking at a second location, likely in the Pacific Northwest. A very similar wood basket, very similar decline in paper industry, and one where we can support that industry by using those byproducts of other industries. There's the mill. There's an overlay that's starting to come into fruition, which is wonderful. Tall cyclones, which are part of the drying process. And it's a 1980s mill that was shuttered in 2016. And all around a very significant investment, but one that has very positive attributes when we talk about sustainability, when we talk about the environmental impact, and very much part of our mission is that ESG component is the carbon, embodied carbon component, mitigating climate change. And much of the funding for this was tax exempt green bonds, the solid waste bonds that helped move this project forward. We're using wood chips, a byproduct of the industry here in Maine. Focus is on FSC certified byproduct wood predominantly to start. Then we will most likely take some of the cuttings in sustainable forest practice, so the weeding the garden, if you will, and chip that material up as well. But there's an abundance of wood chips that exist here in the Northeast and in other markets. A little flow through where we buy chips from a lumber mill, for example, which would be considered waste. That would be the chips that would go to the paper industry in the past, and not so much anymore. We're providing an outlet for those businesses. We process that by injecting steam and then refining or milling those chips. In the case of a board or a bat, there's some additives. In the timber fill, very little is added and it gets bagged up, ready to be blown in. And really focused on the forest economy. There's an overlay, if you will, of locations we'd like to be and reviving our forest economy, the forest map. That lines up very close. As I said, second location, Pacific Northwest. There are unfortunate results of the decline in people reading the newspaper, not manufacturing paper, and that byproduct, I think, is a significant part. Some of it's being shipped overseas, some of it's being landfilled. And that's an immediate release of carbon. It's not allowing for us to hold on to that a little bit longer. Many people ask us about pricing, very comparable to cellulose, all borate cellulose, very comparable to XPS foam board that would be used on the exterior of a house, a deduct from mineral wool, and somewhere between a mineral wool bat and a fiberglass bat as far as cost. Drop-in replacement. We say this quite often, and the importance of application and support. We're very keen on education and supporting the industry that will be applying the material, and it's really an above grade solution. You can see blown into walls or applied on the exterior. Top right is retrofit in Belfast, where board is being applied. Much of this is all European product at this point. It's a College of the Atlantic in the bottom left, and sister company Opal Build laminated wood fiber board and CLT for a small school and a demonstration school here in Belfast as well. Really extensive abilities to get into most construction types, certainly up to type 3, 1 and 2 in some applications. But our primary focus will be on the residential market and light commercial. First product coming soon in April. It's a blown-in material. We're generating instructional videos and documentation to support installers, and should be very familiar product, around a 3.8 per inch. And we add borates, very much like the cellulose industry does currently with their materials. The borates are fairly benign mineral salt that gives it a Class A fire resistance. Timber bat to come July, August, around that time. We're adding a little bicomponent to that same fiber stream, continuing with the borates as well. And this gives it structure and allows us to create something with loft that will fit in a 16 or 24-inch cavity. We'll be also applying or being able to apply in metal frame as well as wood frame walls. One of the big things we talk about fire, water, and bugs is the concerns that people raise. And this is a section of bat. And we're applying fire, as you can see. And the interesting thing with the Class A product is that it's not ever going to be flame proof. But the chemical and the density of the material caused it to self-extinguish very quickly. The board is much denser and there is no fire retardant added. But as mentioned in the earlier presentations, there is with heavy timber, there is a certain charring on the surface that happens because of the density of the board, and it is very flame resistant. It ends up being a Class B. We will most likely go to market with a Class A board as well. We have to iron out the chemistry, if you will, at this point, but that will allow us to expand this offering into the commercial sector. Our values are a little lower, 3.4, 3.5, depending on the density of the material. One of the things that's really unique and interesting about board and wood fiber in particular is some of the buffering that can happen with humidity, but also with temperature. Above and beyond just standard R values, there's a certain amount of absorbing of heat. It has a great heat capacity as well. And we're very excited about the implications of Maine in particular and other states taking on more current code cycles. It means greater efficiency. It also means being able to wrap the building with products like our board to not only increase that efficiency of the building, but the comfort as well. We are exploring the options of other materials from the construction industry. Spruce pine fir is a predominant tree species for lumber, and it's exactly the kind of material that we could process into chips. Some of the cutoffs of our manufacturing go back into the cycle to be created into that one product that we're working on. There's no reason why construction waste and debris could not be used as one of those options. And certainly the carbon story is very compelling. Most of us, I think, understand the principles of the carbon cycle and the opportunity to take that high embodied carbon from trees to lock that into the building for the lifetime of the building means really great things when we talk about reducing our footprint. We do have a very strong social component. Feel free to reach out to us through those channels, whatever you particularly use, or good old-fashioned phone call or email as well. And I'll stop there. Thank you.
Thanks, Jason. Great overview of, I think, just a really neat and innovative product, and one that, as you showed, is very, very easy to see kind of the market potential for that product. So to our audience, please, we've got a couple of good questions in the Q&A, which we'll turn to in a sec. Please continue to keep those coming. I'm going to start with one as we get into the discussion with our panelists for all of you, which I'm struck. I mean, you just showed us, Jason, in one of your final slides, how the story behind your wood product, where it comes from, the environmental benefit, the climate benefit, things that relate to the fact that it is fundamentally wood, seem to be a pretty key part of your brand identity and your marketing. And I saw that, for Amelia, you and you, Donna, as well. So the question is, I guess I'm curious how your customers respond to that, and do you feel like that's giving you an additional competitive edge in selling your product and commanding a good price for it, or is that a bit, how much does it make a difference, I guess, in the buying decisions that you see people making?
Well, I think one of the things that we realize is that there's a community out there that has been bringing wood fiber into the United States from Europe for a long time, 10 years or more, the Passive House in particular, and net zero. And there's a focus on the bio-based solutions in the building environment, and that's awesome. And we fully support that industry. But there are merits, very much like WholeTrees, and the structural aspect of it. There's just good sound science behind the materials, and we kind of gotten away from some of that and that connection. So we lead first with performance. We're not the highest R value, but I can talk through additional aspects of summer heat protection and other things that wood fiber is much better at than foam or other products out there. And we're not trying to be all things to everyone. There are wonderful applications, and I think we are very mainstream, or can be, and by our readily available raw materials and the lower costs that we have here in the States, we feel we can go to market as competitive as others and not come across as a premium product. We really want to be, I like to say, the carbon sequestering sheep in wolf's clothing, maybe, to go to market with some really wonderful merits in a very conventional way.
Mm-hmm. Yeah, Amelia.
I relate to what Jason said in that one's business model is stronger when one can appeal to a wider range of interest than, say, just the sustainability play. What WholeTrees has found, though, in contrast to what Jason said, is that the longer we can take advantage of these earliest adopter markets, the longer we can remain a premium product and have stronger margins. So we find that our earliest adopters are drawn to us because of the sustainability story or the aesthetic look and the kind of the brand that our material brings to their entity or their building. And we have decided to take advantage of that and to continue maintaining a role in the premium realm for as long as possible, rather than scaling as fast as one could or needs to if they're a more mechanized product. There was a question here about when will mass timber scale faster, and laminated products, they have to go into bigger buildings to be cost competitive with steel and concrete. They can't, smaller projects with laminated products aren't as viable economically. So you have to scale, you have to bring your prices down, and you have to appeal to a much wider audience. And I guess with innovative wood products, it kind of depends on how big are you trying to go and how fast. How big do you have to go to make your economic model work? And I think, Jason, your model, it's very capital intensive in the beginning. You have to go way beyond in sustainability very early on. I think you're making the right play. At one point, we thought we would too, and later realized, gosh, the economics are smarter for us to play into the early adopters making decisions on sustainability. So I think the answers we have that are different are actually quite interesting and show a lot about our industry.
Yeah. Donna, how about you? You're also in that spot, I know, of looking at, traditional smaller market, larger market potential. And so that question, and also the question of how much the story behind your product fills in to your ability to sell it.
I had a question for Jason first on the carbon credit market. I mean, is your product eligible for carbon credits? Has that been looked into?
There may be, I think there's a potential for double dipping. And we are not foresters. We are only buying a byproduct of either someone practicing sustainable forestry or a business that is buying FSC certified, for example. We are focusing on the carbon aspect of the material and looking to do environmental product declarations and that sort of thing. But I don't know, to be honest, following the carbon credits, but I'm assuming that that's generally focused on the woodlots themselves and that practice itself.
Well, you are sequestering carbon by producing this insulation.
Absolutely. And we are very proud of that and very excited to get a year's worth of data so we can actually document that in a type 3 EPD and share that information.
Yeah.
There's no doubt the European model, looking at the EPDs overseas, have significant carbon storing potential, especially as you get into the denser products like the board product.
Right. Well, we're certainly very small scale here. And like I said earlier, our biochar, because it's a manual operation, I need 2 people operating that unit for 8 hours to make 400 pounds, a little bit more in an 8-hour day. So when I'm charging a $4 a pound rate, it's a premium product. And it's excellent biochar. There's no doubt about it. It's at least 85% hard carbon. It's a great product. However, these sophisticated units that are coming into this country, one in Maine, standard, they're going to be able to sell their biochar for 40 cents a pound. So I can't compete with that, which is why we have to pivot now and start to think about the markets for that biochar, where they are creating those markets ourselves, whether it's to farmers. We really think it's excellent to put into manure pits before the manure pits are emptied and sprayed on the fields, because it will prevent runoff. It will build soil carbon. It will reduce the need for excessive fertilizer and water use. Those are all good things, but farmers can't afford this right now. So it's going to have to come from funding from other sources for them to afford that biochar. But at 40 cents a pound, now we're talking a little more level playing field. So we are pivoting to becoming farm service providers, as well as selling and packaging the biochar direct to consumers. There are other markets for biochar. One is to actually export it, because all the coal burning facilities in Europe and the UK, they're going to cease operations. They're going to need fuel. That biochar, because it's a carbon, can be a substitute for the fuel. Also, the steel industry needs carbon. So we've got another market there. By placing a big unit in either Maine, which one is there, or Vermont, we have good access to the terminals to ship this product overseas, which we're looking forward to as well, until we can build up the market here so farmers can afford it, so consumers are more interested to buy it, mixing it with other composted materials like food scraps. So there are markets. The feed market, I'm actually starting to network with veterinarians from some big food production, Tyson Farms and Purdue. We can't give it to our livestock in this country yet, but in Europe they are, and so that's another market for it. It's being used to mix with cement to create a durable product, and for the same reason, sequester carbon while you're doing that. It can be mixed with asphalt. They're using it in Africa, on roads in Africa. So there's a lot of uses for it, and there's a lot of rabbits you can chase, and so right now we're pivoting. Our 400 pounds a day isn't going to cut it. So now we need to learn how to network and work with those that are. And that's where we are right now.
Great, thank you all. I want to turn to a couple of questions from our Q&A. I think, yeah, the fire question always comes up, I'm sure, right? When talking about building with wood, and Jason, you had that great video, but there's a question about the off-gassing properties of your products during normal use and during a fire situation. And is the release of toxic gas less, especially during a fire? And if yes, is that information being used and as a marketing tool?
Yeah, I mean, each of the products grow in complexity. We've spaced out the production release or ramp, if you will, just to not overtax the engineers that are coming up with the systems that make all of these things. And the first one's very straightforward. The predominant, from my understanding, one of our co-founders is a PhD materials chemist. The other is a passive house architect, and they may have more details on some of this. But from my understanding, VOCs, just nothing to do with combustion, just what a material would off gas. And I think the major VOC contributor in our product is going to be the pine chips. And that may speak to its toxicity, if you will. There are volatile organic compounds in all sorts of things. But when we start talking about fire, it is wood that is burning predominantly when you char that. Borates slow the combustion down. We do use a little bit of polyester, a bicomponent in the batt that gives it its structure. And then when we get into the board, probably the black mark, if you will, in the wood fiber industry is the very small amount of MDI. This is Gorilla Glue. It holds it together. And there are some ways around it, but then the performance declines and it becomes more brittle and harder to handle. And there are trade-offs in all of that. Under 4% MDI in a board, the rest of that 95–96% is wood fiber. The charring is largely due to the density. If we add the borates, but absolutely, we are looking to market the health and safety, high performance, healthy planet, healthy people, not to make them secondary, but just to focus where we're heading and why, and the rest follows nicely, I think.
Yeah. Amelia, how about for you?
I noticed that was an interesting question. We have very low toxicity, and we do have that certified both through a Declare label, through the International Living Future Institute, and we've other health and wellness catalogs, but we're largely just timber, which means that there are not a lot of additional toxins other than the kind of stain chosen for the exterior by our specifiers. In terms of it being a selling point, in the commercial industry, there is an interest in healthy materials. Yes, especially in the interiors realm, interior decor, tenant improvement. But we're so far on the spectrum over to low toxicity that it doesn't play into how we market ourselves or who's choosing us. I think more important to us is our environmental product declaration, which is new and useful, and it gives data to the effect of how much we're contributing to global warming potential, et cetera.
Thank you. So Donna, I mentioned wanting to come back to sort of the scale up of biochar, and there's a question about this from Claire in the chat about, and I don't know these acronyms, hopefully you do. USBI and IBI have stated that scaled up biochar production is achievable and can reach up to 3 gigatons, that's a lot, of carbon storage annually, which is 30% of the IPCC's annual atmospheric carbon removal and storage goals for for 2050. Is that, is biochar shovel ready enough to scale effectively to meet that potential? And I guess I would add too, like, what would be the ramifications of getting to that scale of biochar production?
I do trust USBI, that's US Biochar Institute, and International Biochar Institute
Thank you.
for coming up with those amounts. I believe that to get it scalable, we're going to need more than the agriculture industry. We're going to need the building industry. We're going to need biochar to be accepted as a food additive. There are a lot of markets that biochar can play into. Also, its ability when they are in production, these big machines, they're actually turning energy back into the grid. And that's probably the biggest player here. So yes, I believe it can happen. And it's starting to gain momentum, but there's going to have to be some serious investment. Those kilns that are, I'm calling it a kiln, that's going to make 3,000 tons of biochar a year, you're looking at $5-8 million. So how fast is the turnaround time to make a money off of that? I can't say. I can't say. I think it's in the next 3 years. Yes, I think it's happening. The carbon credit market is huge for biochar. $200 a ton. You're making 3,000 tons. That's $600,000 a year. Well, you've just facilitated a whole lot of payments on one of those units. But you still have to prove that you're sequestering carbon. You can't just make the biochar. Now you have to put it to good use. And that's either getting it in the ground, adding it, to cement for roads, for buildings. I think it can happen. Yes. I'm cautiously optimistic. Let's put it that way. And I'm glad I'm, still in the game and paying attention and trying to pivot with it all. And my heart is actually in, I live in a rural part of the world. I want to create good jobs for people. I want to put people to work. I'm not looking to build a company that I'm going to sell in 5 years and pay back the investors. I want to help. You know how many loggers we know up here, in the Northeast Kingdom? We want to help them out. I want to be part of the solution. I'm not here to create a company that I'm selling in 5 years' time. So, yeah, I'd say there's a good, and again, I trust USBI and IBI. There's a lot of people paying attention and know their way around the biochar industry.
Yeah, well, Claire, hopefully we spoke to your question, but if not, you can come back at us in the Q&A. But I think, again, I don't know all the acronyms and the words, but I think the scale of wood consumption that might be needed, the amount of wood that would need to be turned into biochar to meet those goals, I think is something that would, that's what I'd be curious in, because I think that's always a question as new products and uses of wood come into the market. How do they relate to other existing markets and uses of wood? One, ensure that there is supply available for lots of different products. And I think also editorializing a little bit here, but just to maintain a diversified set of markets and products for wood products, rather than going at a massive scale into any one thing. So I think that's already been proven in this region that eventually that ends and industry has to reinvent. Another question, and sort of related, is from Charlie about and I think you all spoke to this generally, but how much wood do you use every year, and generally where do you source that from? And I know that would be in some cases reiterating something you've already touched on.
I did answer one question in the chat about volume, and spruce pine fir is predominant softwood species. We're exploring others. We've got a grad student exploring hemlock for us. We could use some hardwoods. It's coming from Hancock lumber, from Robin It's coming from the foresters that are supporting us, the logging associations that have invested in our company, as they are responsibly thinning forests to increase better wood stock. But yeah, it's and as far as volume, I think that the mill in Madison used about 500,000 green tons a year, and we're expecting it peak to be about 250,000 in that one location.
Thank you. Amelia, I know your product's a little different. Do you have an idea in terms of, wood consumption?
We do. And every year it's growing because we keep growing. But the difference for us is that we pay a lot more per ton for the timber we buy, but we also use less. So it's a higher value, lower volume business model. We will, I have like a chart of how much we're going to be using annually in Maine, and I'll pull that up perhaps while someone else is answering, because the number's not on the top of my head. I will answer where we source from. We source from regional generally private foresters managing their forests to either certification levels or sustainability levels that meet a kind of a standard of checks that WholeTrees has. And we buy from landings in Wisconsin and Illinois, in Oregon and Washington, those, and then occasionally we'll source from North Carolina for white oak and black locust. One other thing to say about that is the market development we've been doing in the last 2.5 years. We've been studying of what we sell, which contracts are applicable to Northern Maine products. And we, within our 2 years of working with Northern Maine forests, we're able to we have about a $15 million sales funnel for the year, and about $5 million of that last year was applicable to Maine species, and that's growing. And so for WholeTrees, often it's about where have we sourced, but as we move to new regions, what could we source instead? As for the tonnage, actually I have it modeled out. Maybe I'll pull it up while others are talking.
Thanks, Amelia. And Donna, I think you already covered, I believe it's about 4,000 pounds a year in biochar production, so double that in terms of wood consumption. But then, as you described, opportunity to scale up.
It's 4 times. So for every ton of biochar, I need 4 times as much wood waste, wood chips. So if you're looking at the 3,000 tons, I believe it comes to like 12 million pounds of waste wood that we would need to produce the 3,000 tons. So yes, that's a lot. Right here in Orleans County, there's a furniture manufacturer, Ethan Allen, that also they're using wood chips to for their heat in all their plant. And it's my understanding that might pivot in the next few years, that we're not going to be allowed to do that. I'm not 100% sure. So I think there could end up being a glut of waste wood available that we can utilize. So time will tell on that.
Yeah, well, as you said, Jason, I mean, the volumes of wood that historically went into pulp mills were very large. I mean, I know a couple of years ago, after a slate of paper mill closures in Maine, there were millions upon millions of tons of wood that had a home pretty recently that no longer did. So that was sort of viewed as frankly, I mean, a challenge for the industry, but also a market opportunity, because all of a sudden here's a raw material that is already within the carrying capacity of what the forest and the forest industry can produce, that I would argue created openings, for companies like yours to come in and say, hey, we can use that same source material, but for a new and different product.
Yeah, we've had quite a number of mills closed in the last 10 years here in Maine, and there are still some in operation, but that was the major revenue stream for folks that were milling lumber, for example, and they did not have that for a while.
Yep. So we touched on already, clearly there's some interplay in the, in the building realm between mass timber, wood insulation. But I'm curious to ask all of you, are there other innovations in the wood products realm that you're aware of, that you're excited about? Either generally or also ones that you think might be complementary to or help you grow markets for your own products? Amelia, go ahead.
There we go. In my realm, there's been I'm interested in glulam column systems and column and beam systems. There's been such a draw and fascination with cross-laminated timber panel systems for the walls and ceilings of taller buildings. But to do a mass timber structure, you also need beams and columns, which is where WholeTrees has been playing. We are a complement to glulam, but we also notice that there may be a bottleneck in demand for glulam columns as mass timber structures increase. We're all focused on how do we ramp up cross-laminated timber fabrication facilities with a little bit less focus on glulam facilities. And I think there's more opportunity to bring smaller amounts of regionalized species into glulam engineering than there is into the mass panelization of CLT. So as we grow, continuing to watch how regional wood is being engineered into glue laminated column and beam systems, and then figuring out ways to overlap our business model and growing into the glue laminated space as well. When it allows for regional sourcing, that continues to be my interest, is the prosperity between forested communities and their forests. And I think that glulam allows for a bit more regional sourcing potential into the future that might overlap with our current markets.
I would just add, I think Amelia answered the CLT question in the chat and just mentioned it again. And it's very exciting to see more wood in construction, and I think it's a wonderful thing. But we have a Opal sister company, and they've done a number of projects with CLT. And in doing those, they've imported German wood fiber because we're not producing it. And they've also imported German CLT because that was the most precise and accurate and great to pop together like Legos in a residential application. But it's not ideal on a small scale. When you start getting to a very large scale, then there's a great impact. And maybe it's just floors, maybe it's floors and ceilings. But I think it seemed like the easy answer, but I think it's important in anything that we do to pay attention to carbon, the carbon impact, the harvesting of those materials, how they're being used. And I like the idea of creative solutions for sure. And I would welcome CLT facility in Maine or in the Northeast, but it's, I think there's much more to do with the materials, the raw materials of other industry, the smaller materials that may be less ideal to do the laminations on a larger scale. And I'm assuming with laminated timbers, that would be along the same lines. You could use a wider variety of what you harvest in that scale than you would in CLT.
Donna, what are you? Yeah.
I just have a question for Jason on the average cost per ton of wood chips that you're paying. Will you reveal that information?
If I knew it, I would. I don't. We have not been producing yet. We have bought on a very small scale for some pilot testing that we are about to embark on as we're almost ready to release a product. But I'm assuming with scale that, that's something that will benefit us, because we're going to be very consistent taking truckloads in on a regular basis, but I don't. I can follow up after if I learn what that is, Donna.
That'd be great. Thank you.
Okay, we're nearing the end of our time, so we'll wrap up here shortly, but I think there's one question. I think this is probably best for you, Amelia, from Nevin, about resources for unmilled or minimally processed trees to use at scale, particularly in low-rise construction. Do you have a thought on that, including your own company?
When he said resources, does this mean capital resources or timber and fiber basket resources?
That's a-
Or maybe you don't know. Can I guess?
Yes,
Maybe
you can guess.
I'm going to
What-
assume he might mean,
He says
Cap-
learning resources. Thanks,
oh,
Nevin.
specification resources, perhaps how to learn more about this. Well, first, contact WholeTrees. We've got a whole library of materials, everything from general data reports and material science reports from the USDA Forest Products Lab here in Madison, Wisconsin, which is where I'm presenting from, all the way through kind of a decade of library of news articles and relevant product partnerships that we could kind of hear a little bit more about what the resources are that you're looking for, and WholeTrees can direct you in a certain direction. And then the USDA Forest Products Laboratory website is an amazing resource when it comes to reading synopses and abstracts on just about every single forest product innovation out there. But I'm not sure whether you mean resources to learn how to specify structural timber. And if that's what you mean, I'd have a different answer, and it would still say contact WholeTrees. Info at WholeTrees, and we'll direct you in the right direction.
Thanks, Amelia.
I also learned that for every million in WholeTrees sales that we make, we buy between only 1,000 and 2,000 tons. And so it's very low volume, but we're able to pay between $350 to $600 a ton, which is really quite high. In our feasibility study, we are looking to ramp to 10 million in sales each year, which comes to about 10,000 tons of extremely high value timber coming through that facility.
Great. Thank you. Well, I'm going to start to wrap us up. I want to thank again all three of you for taking your time to present your stories, your companies today, and for good discussion. To our audience, hope you found what you were looking for when you signed up for this webinar in terms of some exposure to innovation that is happening in terms of new products from northern forests and some of the opportunity ahead. Look for an email. This is for our participants from my colleague Kendall Gray. Will send out afterwards with a link to the recording. We'll include resources and links to our three panelist companies, as well as potentially any answers to questions that we didn't get to during the session. But again, a little virtual round of applause for Amelia, Donna, and Jason. Thank you all so much. A few quick announcements and housekeeping as we wrap up. The Northern Forest Center is grateful to a number of agencies and entities like the Northern Border Regional Commission, Economic Development Administration, and the U.S. Forest Service for supporting our work and our ability to host sessions like this. We do have a regional, one of the programs we run to support the forest products industry is a regional CEO peer-to-peer forum called the Northern Forest Board Forum that meets monthly. And we have a couple of openings in that group. There's a little info here on the screen, and you can contact my colleague, Amy Robinson, who kicked us off if you have questions or interest in that. Northern Forest Center webinar series continues on March 14th with a session on encouraging entrepreneurship in Northern Forest communities, related, of course, to today's topic, but really more broadly thinking about the types of entrepreneurs who are setting up shop in rural communities across the Northern Forest. And then in April on the 19th, back in the realm of forest and the forest economy, we're going to host a conversation on ensuring the long-term forest health and resiliency here in the Northern Forest. So again, to our panelists, thank you so much. To our audience, thank you. For those of you in the Northern Forest, enjoy the impending snow. Winter's not done with us yet. Thank you, and we'll see you next time. Take care.
Thanks, everyone.
Bye.